Another form of measuring angles is a method known as radians. You should have talked about radians a little bit last year in Math 2. So hopefully this will be somewhat of a review, and we'll just continue talking about radians. Take a minute and see if you can remember what a radian actually is, if you remember. To help us remember, let's look at this. Alice, Javier, and Veronica are responsible for preparing a recently discovered archaeological site. The people who used to inhabit the site built their city around a central tower. The first job of the planning team is to mark the site using stakes so they can keep track of where each item was located. Each discovered item was located. So Alice suggests the team place stakes in a circle around the tower, with the distance between the markings on the circle being equal to the radius of the circle. Javier likes the idea. So let's think about it here. If we have the circle here, they have two separate circles. So think about the inner circle. Has a radius right here. If we were able to take that radius and place it around the circle, so kind of going around the circle, how far would that go? It would probably go to about right there. Okay. How many of those could we get around the circle? Well, if we kept measuring, the next one would probably be to about right there. The next one would probably be to about right there. About right there. About right there. And probably about right there. So how many times have we gone around? I keep hitting that. Sorry. Go away. Okay. So I've gone around once, twice, 3 times, 4 times, 5, 6, and a little bit. So about 6 and a little bit. Question is, if I look at the bigger circle, so if I measure that radius, will that be the same? How far around, if I were to start here, how far around the circumference is one radius? Well, if I keep going, how far is that going to be? Weird as it may sound, it's going to be about the same right there. So for the bigger circle, how many are there going to be? Well, there's 1, and if it's about the same, there's 2, 3, 4, 5, 6, and a little bit. For every circle, that one radius around is actually going to be the same right there. This distance right here from here to here around a circle, or from here to here, is what is called a radian. Maybe you remember that from your class last year in Math 2. So exactly what is a radian? Again, as I explained, you take the radius, lay it along the circumference of the circle, and that length right there is 1 radian. How many degrees is a radian? So 1 radian is approximately 57.2 degrees. So if we say about 57 degrees, that's about how much 1 radian is. And how many radians are in a first circle? We actually kind of saw that in the last slide. There are about 6.2 radians, so a little bit more than 6. However, we often use this term 2 pi. So radians is just another way to change from degrees to measurement, to another way to measure angles. We can measure angles in degrees, and we can also measure them in radians. So how do we measure them in radians? I don't know if you guys have ever done like unit conversions, but that's really what this is. Okay. What we're going to do is just really multiply this by a fancy looking number 1. So I'm going to take this 225 right here, and we're going to think, okay, how many radians are there in degrees? So if you've ever done unit conversions, you know there's 360 degrees in a circle. I want to put degrees down here because I want to be able to kind of cancel off those degrees. How many radians are there in a full circle? From what we had on our last slide, 2 pi. So right here I'm going to multiply this by 2 pi over 360 degree radians. We can actually simplify this a little bit. If you notice 2 and 360 can simplify. So I can actually do 225 times 1 pi over 180 degrees. Then we're just going to simplify that. 225 pi over 180. And when you're simplifying, really all you're doing is simplifying the fraction. We leave these in terms of pi. 225 over 180 simplifies down to 5/4. So we're just going to leave this as 5/4 pi. Just leave it in terms of pi. Same thing with negative 345. What we're going to do, instead of multiplying it by 2 pi over 360, I'm just going to multiply it by pi over 180. That's a 180. See, my handwriting is just as bad online as it is in the classroom. So again, keep that pi with it. So negative 345 times pi over 180, and all we're really simplifying is that right there. Simplify that fraction, so you get 23 pi 12ths. I'm going to let you guys do those other two. If you need to pause the video for a moment, figure out those other two, see what you can do. Hopefully you pause the video. Here's the answers for those. See if you can get those answers. What about going the other way? Changing radians to degrees. Well, we're going to kind of do the same thing. I'm going to think, what did we multiply to change degrees to radians? We multiplied this right here. Oh, let me get the pen out here. We multiplied this. Change degrees to radians, we're actually going to multiply by the same thing, except we want to get rid of the radians, so we're actually just going to multiply by the reciprocal of that, 180 over pi. What happens here is these pi's divide out. So really what I have here is 3 times 180 divided by 2. Get your calculator out. I would enter that in just like that. And our answer right here should be 270 degrees. Again, 55 pi divided by 18. We'll multiply that by 180 over pi. The pi's go away. We're left with 55 times 180 over 18. Again, enter it just like that into your calculator. Get your calculator out, whether you're using the Desmos calculator or another calculator. You should get 550. Try those other two on your own. See what you can do. Again, pause the video for a minute. See that you can do those. Those answers should end up to be that. So those answers for those last two should be like that. So to sum it all up, really, and this would be another good thing to maybe write down on your little half sheet of paper. Change degrees to radians. When you want to change degrees to radians, that's what you got. When you want to change radians to degrees, that's what you got. Okay? So again, there's some practice on there for radians and degrees. See what you can do. Have fun. Good luck.